All right, so 4-8 is the last section before your test on 4.5 to 4.8. So,
I said that I have a giant project and
I don't care. All right, so example 1, we're just going to have some application problems. And so we are going to use my 4-step plan. So this one says a safety regulation states that the maximum angle of elevation for a rescue ladder is 72 degrees. Because you're going to measure that, I'm sure, right?
Of course.
If a fire department's longest ladder is 110 feet, what is the maximum safe rescue height?
Do they need to know this?
I'm sure they do. Sure, it's on the fireman's test. So now I'm teaching to those of you who are going to become a fireman.
Yeah.
All right, so let's say that this is the building. There's your building. Wouldn't this be a ladder resting against the building? We're assuming that the building makes a right angle with the ground. True? You are going to need your calculator, by the way. These questions you had, by the way, these types of questions in geometry 2 years ago.
I don't remember geometry.
All right. So let's label in the picture what we've been given. So I've been told that their ladder is 110 feet. Is that this distance, or this distance? The hypotenuse, very good. So this is 110 feet.
Oh my god. This 4-step plan.
Yes. Picture, this is your let statement. We love this. It makes you a better problem solver. Quit complaining. All right, then it says the angle of elevation for rescue ladder is 72 degrees. Wouldn't this be the angle of elevation at 72 degrees? Because it's going up, right? If a fire department's longest ladder is 110 feet, what's the maximum safe rescue height? Is that this distance here or this distance here? Okay, so the X represents from here to here. That's the highest that they could go rescue somebody with.
Is this similar to like the angle of elevation?
Correct. We use that knowledge here to figure out where the 72 went. So the 72 degrees is your angle of reference, is it not? Then I only have two sides of the triangle that we've talked about. Is this side, the X, the side opposite, adjacent, or the hypotenuse? Opposite. So this is opposite, and this is, Matt already said, the hypotenuse. So that's our first step. Our second step is set up our equation to solve. Our equation to solve, remember, is sine, cosine, tangent of some degree is equal to something over something, right? So is this sine, cosine, or tangent that deals with opposite and a hypotenuse? Sine. That's why we know it's sine and not tangent and not cotangent. Do I know the degree measure? 72 degrees. Then this is going to represent, because it's sine, opposite over hypotenuse. So my opposite is x, and my hypotenuse is 110. You have to make sure you have those in the right order. Then we're going to go ahead and solve. If I were you, I would make this into a proportion. You're going to solve straight down. Don't we cross multiply to solve? So x is equal to 1 times x, 110 times the sine of 72 degrees. What do you have to be careful of? Right. What are we putting into our calculator? Degrees. So what do we want our calculator in? Degrees. Very good. Is my calculator in the correct mode? No. So I'm going to highlight degrees, hit enter, and then do second quick. So now I should come up with the correct, hopefully, the correct solution. So 110 times the sine of 72 degrees is equal to. Does that seem reasonable? For a height, right? And the height of the ladder, shouldn't that be the longest measure in this triangle? So we expect this to be less than 110 feet, and didn't we get less than 110 feet? So round, they didn't tell you where to round, so round to 2 decimal places. So 104 point what? Feet. And then your therefore statement. Therefore, the maximum safe rescue height, oops, is about, because we approximated 104.62 feet. Yep. I want to see the picture. It's really important that you draw a picture of what's going on. Yes?
Okay, so if we do everything that you say, but if we don't do it in the 4-step plan, will I get points off? Or
No. As long as I see everything. I've got to see a picture, an equation to solve, a proper equation to solve, not one that you've already solved. You know what I mean? In other words, this is not the proper equation to solve. And then I have to see a sentence answer. Yes.
Is there any way to check the answer?
Other than that we checked it for what seemed reasonable, that we knew it had to be less than 110 feet.
Yeah.
So
just
that would
the
seem reasonable.
hypothesize the biggest one.
Correct. Okay, then we're going to talk about bearings. You've heard, okay, we discussed that I can't find my way out of a paper sack, right? Okay. So this would be a tough issue for me to actually talk about this, but we're going to go with it. All right. So we're going to look at what does it mean to be south 35 degrees east.
Say what?
Here's where my two colors come into play. So they've given you two different directions, correct? The first direction tells you essentially what axis that you're on, and usually north and south are going to come first. So it determines whether you're on the north axis or the south axis. And then the east or west bearing typically comes second, and that'll tell you if I'm on the north axis and I'm heading a bearing east, that means I'm going in this direction, which creates an angle, doesn't it? Or if I'm going west, I would be going towards that direction. If I'm on the south angle and I'm going in an east bearing, I would go towards that direction. Or if I was going to west, I would go towards that direction. What? I know. Were you in Boy Scouts? I, as a girl, wanted to be in Boy Scouts, but my mother wouldn't let me.
You can be a yeah, I know.
Now it is co-ed, I know. It's awesome. All right. Shh. So watch what happens. Watch what happens. I agree. Well, okay, I was Girl Scout leader. I was an excellent Girl Scout leader.
Yeah, Girl Scouts is fun until you get older. And you
We'll have a discussion about my opinion of Girl Scouts versus Boy Scouts after my video. All right, here we go. So south is first. So south is this axis right here. That is your initial side, okay? Then, if we're gonna go 35 degrees, and it's towards the east, so it's in this direction, oh, it might be about this, wouldn't it? So my 35 degrees east represents going from the south axis towards the east, 35 degrees.
So that's what we do with
So this angle right here in pink, that I've drawn here in pink, that's your 35 degrees east. So this would be the direction I would be heading, this direction right here. If I'm heading south, 35 degrees east, I'm actually traveling on this line here. Does that make sense? This is my line of travel. I am not going directly south. How many of your parents have, or you, have a car that has the direction bearing on it and it'll say like southwest? Okay, I'm not actually traveling directly south. Most of the streets here in Phoenix are north, south, east, west streets, correct? If you've ever lived, I've never really lived outside of Phoenix, and this is why I'm directionally challenged, because we are so logically formatted here. You go up to Washington State, I mean, their street addresses make absolutely no sense whatsoever. So, yeah, there's no logic reasoning to it. So my point to you is this. Southeast means I'm traveling in a southward direction but towards the east. So if I'm going southeast, I'm somewhere between south and east. How far southeast? 35 degrees. Does that help?
The extent because I don't like southeast because
Okay then. All right. So north and then 80 degrees west. So I want you to put down there what you think it might look like. So north would be from this axis, correct? Up here. And if I'm going west, it means I'm going in this direction, right here, 80 degrees. Well, 80 degrees means I'm going 80 degrees from the north axis. So the 80 degrees is going to be measured from here. So it really means I'm probably about this far over, give or take a few degrees. So the 80 degrees goes from the north in this direction west. This angle right here is your 80 degrees west. Because you're going from north and you're going to the west 80 degrees. It's a little different to think of it that way. Yes?
Do you like care, like, gives you like a slight difference in the angle?
No, I don't care, but you need to know where the degree is. In other
Okay,
words,
what
the 80
quadrant?
degrees belongs between these two lines here.
Okay.
The 80 degrees is not here, and that's what's important for you to note is where is that 80 degree bearing. The 80 degrees comes from the north axis to this. This is your line of travel, right here. This black line is your actual line of travel. The bearing comes from how far off of that north axis are you traveling. I'm traveling 80 degrees west of the north axis. Doesn't that make sense?
Yeah.
But this is my line of travel. And we're going to apply this in just a minute. That's going to get a little confusing. But you'll have to stay with me. All right, here we go. Just a little. All right, so now let's do north, but 45 degrees east. So you write what you think that looks like. What axis do you start on? And what direction does it go? And where is that 45 degrees?
Would it be cheating to use a GPS?
Yes. No GPS, no compass allowed. So you're not allowed to wear shoes that have a compass in the toe. Although I couldn't read it anyway if I brought them in.
Wait, someone did that?
I have a pair of boots with a compass in the toe. Didn't I tell you the story? When I get myself lost, I've gotten myself lost so many times that my husband and twin brother thought it would be funny to buy me a pair of boots with a compass in the toe of the boot. The problem is I'd have to take the boot off to read the compass because I'm so blind. Yeah, so I told him it did them no good. All right, so here's the north axis, correct? Shh, here's the north axis. Listen up. I am traveling 45 degrees to the east of that north axis. So 45 degrees would be straight up through the middle, wouldn't it? And 45 degrees east would be this angle measure right here. This right here is 45 degrees east. Now is it making more sense? Okay. Yes. Oh, you're stretching. All right, so let's look at the word problem. This is our last problem of the day, and it's a Friday, so that's good. All right, so I'm going to, I know, time for lots of questions. All right, here we go. I'm not going to draw my little four-steppy thing because I need a little bit of room, and I might have to adjust where I'm writing things. So please make sure that you draw what we're going to draw, at least save this much room, and we're going to draw over here, but we're going to need a little space. A ship leaves port at noon and heads due west, that means exactly west, at 20 knots, nautical miles per hour. That means he's traveling 20 knots per hour. So if he travels for 1 hour, how many knots did he go? 20. If he traveled for 2 hours, how many knots? 40. So you got the picture, right? At 2 p.m., the ship changes course to north 54 degrees west. So we're going to have to figure out what that bearing is and what the line of travel would be. Find the ship's bearings and distance from the port of departure at 3 p.m. Okay. So he leaves at noon and we end up somewhere at 3 p.m. and he made a change in between. I saw that. All right. So first, this is his port of departure, point A. If he traveled due west, and this is at, by the way, noon, which is 12 p.m. It's important to note the time. Oops, uh-oh. And so he headed due west, which is in this direction, right? And he went 20 knots per hour. At 2 p.m., he changed course. So here's where he stops and starts to change course. This is at 2 p.m. How far is this in nautical miles? Yeah, because this is a difference of 2 hours, then I know that this distance is 40 knots. So when I put the 40 knots there, it's not how fast he was going, that's the number of nautical miles, which is knots, that he went. Then he changes course. Here's how you have to figure out how he changed course. So I'm going to make this actually a solid line because this is his actual route of travel, okay? So this is his first route of travel. Then he changed course. From this point, wouldn't you agree that this would be the north-south, and then this would be the east-west axes from that point? Wouldn't you agree? Okay. If when he changes course, he is going north 54 degrees west, this is the north axis, correct? And 53 degrees west would be over here, wouldn't it? So that means he would be traveling along this line of path, something like this. The 53 degrees goes from this point to here, and this would be 53 degrees, 54 degrees west. Do you understand how I know that that's where the 54 degrees is? This is his second line of travel from here to here. And we're creating this lovely triangle, aren't we?
Where?
Right here. Well, we're getting there. We're not done yet. This is where he ends up. So this is point B, as in boy. And he ends up here at, this is 2 p.m. at 3 p.m. He changed course. Did he change how fast he was going? No, it looks like he's going the same speed. So if he went from 2 p.m. to 3 p.m., how far did he go? How long is this? 20 knots. Okay? The question says, find the ship's bearings and distance from the port of departure at 3 p.m. So at 3 p.m., this is the point of departure. We want to know how far we were from the point of departure and where he is at 3 p.m. So this right here, the shortest distance between 2 points is a straight line, is it not? This is our x.
But that's not a right triangle.
No, you're right. It's not a right triangle, but we're going to make one. You're right. It is not a right triangle. However, we can make it into one by doing this. So Caitlin said this is not a right triangle. Can't I create a right triangle right here? And if I create a triangle right here, and we're going to call this point here, let's see, A, B, we'll call this point here C, and this point here D. So for the video purposes, if you're looking at my notes, my points are now different from the written notes. So fix them. All right. If I want to know this distance, and I know this distance right here, I need to find this partial distance, because if I have an angle, and I can find an angle of reference just by this being 54 degrees, I can find this length here with one angle measurement in the whole big triangle, right? And one side measurement using trigonometry. Agree? I can. Isn't that what we did up here? We had one side measurement and we had an angle. Weren't we able to find that one other side? Okay. Well, that's what we're here. We almost have the whole side here. And we need to find an angle. So we're going to find this other part. Here's how we're going to do it. If this is 54 degrees from here to here, what's this whole angle right here? 90. So if this is 54, how do we find this angle here? Yeah, what's 90 minus 54?
36.
So this is 36 degrees. This is going to be my degree of reference right there. So step number 1. The measure of angle BCD is equal to 90 minus 54 degrees, which equals 36 degrees. That's the first thing we just did, right? That was step one. Don't I have an angle of reference on this little triangle, the little right triangle, and a side length? What I would like to know is, actually, let's find this side right here. Honestly, it doesn't matter which side we find, but we're going to find this side right here.
Honestly, it doesn't matter.
Thank
I think it matters.
I'm honest. You do
The
that.
answer's in that.
Why is it 90 minus?
Because this angle right here is 90 degrees, isn't it?
Yeah.
And if this angle right here from here to here is 54, it's still 54 down here, isn't it?
Oh.
And so that's why we took 90 minus 54. Okay? To get the 36. I want a degree in this little triangle here. So I subtracted the 54 from 90 to get that degree.
Wait, why is it still 54? Yeah, I don't understand.
What, 54 where? Here it's 36.
No, but you said.
Oh, because all the way, doesn't matter how far apart these are, it's still 54 degrees. Doesn't matter where you measure the angle. Right? Doesn't matter where you measure the angle, because I could extend this out as far as I need to, it's still 54
But
degrees.
it's just that the dotted line.
Okay, does that make sense? Okay. All right, so then step two, we are gonna find this side here. We're gonna call it, let's call it Z, or Zippy. Yeah, I'm not gonna call it U today. So we're gonna find Z.
I don't want to be a triangle.
So is Z, according to my angle of reference, is this the opposite, adjacent, or the hypotenuse? So this is opposite, and isn't this the hypotenuse? So, set up our equation to solve. Sine, cosine, tangent. Sine of 36 degrees is equal to what over what? Z, opposite, over our hypotenuse of 20. Put this over 1. And won't Z equal 20 times the sine of 36 degrees, which is approximately equal to, let's figure it out. 11.76. Okay, and is that degrees or what? What is that?
Knots.
Knots. Very good, because it's a side length, right? So now we know that side. Then we're going to find this little piece here. We're going to call this little piece between DC Y. Don't I have a right triangle here? Don't I know two sides of the right triangle? I could use trig again, but why when I could use Pythagoras Theorem? So we're going to find Y. What squared plus what squared equals what squared? What are we putting in there? We now know that Z is 11.76, right? We're going to take 11.76 and we are going to square it because that's one of the legs. And we're going to take Y and square that. We don't know that leg. And then we're going to take 20 for the hypotenuse and square that. So I can actually do that on my calculator or without my calculator. I'm going to take 11.56 and square it. And I get 133. Oh, oopsie, poopsies. All right, try that again. 11.76 squared. So good you're watching my back. So then I actually have 138.2976 plus y squared equals 400. Don't we subtract that from 400? And then what do we do with that? And then take the square roots. And we get approximately what? 16.18. And that's again knots. So this, no. So we have to find this actual piece right here, but here's the good news. Don't we know this whole side of the triangle, and don't we know this whole side of the triangle now? Can't we use Pythagoras Theorem to find x? Here we go again. So next, step 4, we are going to find x. So we are going to take the 11.76 square, which we already know what that is. Take the y, not the y, sorry. Well, the y plus the 40, right? So the 16, 18 plus the 40, right? I want that whole distance. And we're going to square that and set it equal to x squared. So on my handy dandy calculator, 11.76. So x squared is equal to 3294.49. And so x is approximately equal to, take the square root, 57 point, yeah, we'll go with 40. 57.40 knots. So we found part of it.
Part. I thought that was the last part.
Well, we have to find our bearings.
I thought we already did that.
No.
Wasn't the bearings number 2 or 3?
No, we have to find, okay, so here's the deal. The question says find the ship's bearings and distance from the port of departure. So here's what we're going to do. Remember, the port of departure, point of departure, was here. So my north-south direction, because this is how I calculate bearings. Yeah. So we know it's what? This, we're trying to figure out what this line is right here. Is it north or south? North. Okay. So we have to figure out what this degree is right here. Well,
Well, if you go with, you know what, that little,
Wouldn't it be the same?
so if you take that plus 90 equals that one, and then you take 180 minus the.
well, here's the deal. Can I make another triangle? Right?
I'm sure you can.
Wouldn't this be my theta? Right? Wouldn't that be my theta? Isn't this 40 knots right here? What's this distance from here to here? Oh, oops, wait.
And you messed up.
I thought I could make a shortcut for you.
That was gonna be the shortcut.
Can you just change the triangle and just have
I could lengthen it up though. I just drew it in the wrong spot. How about if I draw it from here to here?
Stop it.
Stop making a triangle.
Now wait a minute. Now wait a minute. So if that's okay, so that didn't work. Why? Because I don't know that length. But don't I know that length?
Yeah.
Right there? Don't I know that length right there? No, I'm not.
Yes, you are.
So this, hang on. So this length here, this whole length here on the outside is 11.76, right? Because it's parallel to this, right? And then what's this whole distance here? It's not 40. What is it?
16.18 plus
40 plus the 16.18. So isn't it 56.18? So now I've got two sides, and I can find my angle with two sides. According to that angle of reference, is the 56 opposite, adjacent, or hypotenuse? Opposite. How about this? Sine, cosine, or tangent? Ah. Do y'all agree with her?
Whatever
Yes?
she says is true.
Why did she say tangent with opposite and adjacent? This is my angle of reference. Because, that's right, SOHCAHTOA. So step 5, I am going to find the tangent of theta, it's this degree here, that's going to be our bearings, using opposite, which is 56.18, over the adjacent, which is 11.76. If I don't know theta, what have we learned to do? Inverse, right? So you're going to find the inverse on your calculator. You're going to do the inverse tangent of this, correct? 56.18 over 11.76. Because I want degrees, your calculator had better be in degrees. I'm going to clear all that out. Very good. So we get the second function tangent. Oops, that would be sine. Try again. Second function tangent of 56.18 divided by 11.76. 78 point what? 18. And what is that? Degrees. That is my bearings. So that means that, therefore, now we can finally do our therefore statement. Therefore, the ship bearings is, how do you write the bearings? North 78.18 degrees, and it is to the west. And it is, how far? What was that? So it is about 57.40 knots from the point of departure. So that was a bit of a hairy problem, was it not? Well, look at all that fabulous math. So that's as hard as the problems are going to be, but hopefully you took your notes and you organized them appropriately.
You have one of those on my side.
Oh, we'll have
I'm on the test. But on your homework, yes.